Okay, in this section, we will learn how to solve second-order linear homogeneous equation with constant coefficient. One is characteristic equation have a repeated root. Now let's look at the example. Y double prime plus 4y prime plus 4 equal to 0. Obviously, this equation is a second-order linear homogeneous equation with constant coefficient. Okay, to solve those kind of equation, first thing we need to do, write down its characteristic equation. Then find zeros for this quadratic equation. This one is easy to factor. Okay, it's like r plus 2 square equal to 0. Obviously, when r equal to -2, then the left-hand side is 0. Okay, so r equal to -2 is a repeated 0. That's the only one you have. Remember, in order to find all the solutions for this equation, we need to find a fundamental set of solutions. In other words, we need to find two solutions. Their Wronskian determinant is non-zero. Okay, so for this problem here, we'll only get 1 zeros, so we can find 1 easily. E to the RT. Okay, so R here is a -2. We find 1. Okay, now we need to find another one to form a fundamental set in order to find all the solutions. You got one solution, that's easy. In fact, you can find another one, like 3 times e to the -2t. You can check y2 is a solution. However, those two will not form a fundamental set because they are Wronskian determinant will be 0. You can check that. Okay, so the purpose of this section is to solve this kind of problems. When the characteristic equation have only one repeated 0, what do we do? How do we find all the solutions? Okay, now we want to solve this problem. Okay, now this case we got repeated 0. What do we mean repeated 0? For this equation, repeated 0, this is a quadratic equation. I call equation 2. Okay, equation 2 is a quadratic equation. Its zeros can be found like this. Let me write this. AR squared plus BR plus C equal to 0. What do we mean you have repeated 0? By use the quadratic formula, your R there is minus B positive negative square roots B squared minus 4AC over 2A. 1B squared minus 4AC equal to 0. Then you only get one solution. Okay, that solution there is minus B over 2A. If B squared minus 4AC is not 0, then you will get two solutions. Either they're both real or they're both complex. So once you got a repeated 0 means this condition is true. Then your solution is R equal to minus B over 2A, right? Okay. So in this case, remember my R here is this, okay. My R here is minus B over 2A, which is a repeated root. Okay, so then we can easily find one solution like this. E to the RT. R here, remember, minus B over 2A. Okay, now we want to find Y2. Okay, as I said, if Y2 is like 3 e to the RT, this is another solution, but they will not form a fundamental set. So what we're going to do is we're going to try y2 in this form. Here we don't put a constant here, we try a function. Y is a function of t, then e to the rt. We want to choose v of t such that y2 is a solution. Okay, so we want to find out what kind of condition v of t is satisfied, okay, such that y2 is a solution. What do we mean y2 is a solution? That means you put it back in the equation. You put it back in the equation 1. That will satisfy that. Okay. So we have to take a derivative to put it back in the equation. Now y2 is the two functions multiply each other. We use the product rule. So we take a derivative of first one, give you v prime. Keep this one unchanged. Then plus, fix first one. Take a derivative of second one, e to the rt. You take a derivative, give itself, then there's r here, okay. Here is a v, okay. v2 double prime, okay. Let's take a derivative of this one. Take a derivative of that one, use the product rule again. So you take a derivative of v, you got v double prime, e to the rt. Then plus, fix v prime here. Take a derivative of second one, give you r v prime, e to the rt. Right? Okay. Take a derivative of second one, give you this. Then plus, use the product rule on this one. Okay. So r here is a constant. So take the derivative of v. So give you r v prime e to the rt. The same as this one. So we get twice of that. Then take the derivative of second one. Give you another r. So give you r squared v e to the rt. Okay. Okay, now we're going to put y2 back to the equation 1 here. Okay. So you got a times y2 double prime. So you got a v double prime e to the rt plus 2 a r v prime e to the rt plus a r squared v e to the rt. Okay, let's give you the first term. Okay, replace y by y2 plus b times y2 prime. So give you b v prime e to the rt plus b times r v e to the rt, then plus c times y2, so c times v, then e to the rt. Okay, we want y2 is a solution. That means the left hand side of equation 1 should equal to right hand side, which is 0. Okay. Each term have e to the rt, which is never been 0, so we can cancel this. We'll end up with like this: a v double prime plus 2ar. That's the coefficient of v prime, another one b there, plus b v prime, then plus all the term with a v, which will have this one, ar squared, we'll have v there, then we'll have br, we'll have br with a v, then plus c. All those are coefficient of v, give you 0. Okay. Since r here is a solution of equation 3, right? R here is the root of equation 2. It's equation 2 here. So this term is 0. Okay. Now, then let's look at this. What is 2ar plus b equal to? Remember, what is my R here? R here is minus B over 2A plus B. They give you 0, 2. So that's above equation. Really is A V double prime equals 0. A cannot be 0 because this is second order equation. If A is 0, it's a first order problem. Okay. So V prime must be 0. Okay. So one of the solution is T. Okay. Because T you take derivative twice, give you 0. Therefore, we find out y2 here is V times e to the RT. So my V here is a T to e to the RT. Okay. We can check y1 equal to e to the RT, y2 equal to e to the T times e to the RT. They will form a fundamental set. Fundamental set. So general solution can be written as C1 e to the RT plus CT e to the RT. Then we solve the problem for when your characteristic equation have a repeated root. Now, let's look at an example. We want to solve this equation. Y double prime minus y prime plus 1/4 y equal to 0. And y0 equal to 2, y prime 0 equal to 1/3. Okay, this is the second order linear homogeneous equation with constant coefficient. So first thing to write down is characteristic equation, which is a quadratic equation. This one you can factor like this. If you cannot see that, you always can use a quadratic formula. Okay, minus b here is a -1, so you got a +1 plus minus square roots b squared. -1 squared give you that. Then minus 4 times 1 times 1/4 over 2 times 1. So 1 minus 1 give you 0. So you got 1/2. Okay. So 1/2 is your repeated root. Then you can get one solution like this. E to the 1/2 t. Okay. How can we get another one? We'll learn that t times this give you another one. Okay. Therefore, your general solution is C1 e to the 1/2 t plus C2 t e to the 1/2 t. So for C1, C2 arbitrary, we got all the solutions. Now we want to choose C1, C2 such that those conditions satisfied. Okay. So we need to take a derivative. Okay, take a derivative of first one, give you 1/2 C1 e to the 1/2 t. Plus, take derivative of second one, we'll have to use two terms multiplied together using product rule. So take derivative of t, give you C2 e to the 1/2 t, then plus fix t. Take derivative of e to the 1/2 t, give you 1/2 C2 t e to the 1/2 t. Okay, now, then 1y equal to, here's the function of t. 1t equal to 0. Y equal to 2. Now let's look at the right hand side. Let t equal to 0. C to the 0, e to the 0 is 1. And here t equal to 0, you got a 0. Okay. So t equal to 0, second term is 0. So from here we got C1 equal to 2. Okay. Now, let's find C2 by let y prime 0 equal to 1/2. Okay. So the right hand side, let t equal to 0. This is 1. Okay. So t equal to 0, you got a 1/2 C1. C to the e to the 0 is 0, is 1. Then plus C2. Okay. C2 e to the 0. And this one is 0. So that's it. And we know 2 there. We know C1 equal to 2. So you got a 1 plus C2. Okay. So therefore your C2 here this is 1/3. Okay, I'm sorry about that. 1/3. So C2 is 1/3. Subtract 1, so give you negative 2/3. Okay. Therefore, finally, we solve this problem. Y there is equal to 2 times e to the 1/2 t minus 2/3 t e to the negative 1/2 t. Okay. So we're done. Okay. Now, in summarize, we try to solve this equation. y double prime plus by prime plus cy. We call this equation second order linear homogeneous equation with constant coefficient. Now we can say we solve this problem completely. Okay. So how do we solve it? Write down its characteristic equation. Okay. This quadratic equation has 3 situations. The first one, this characteristic equation, you got 2 real distinct roots, say R1 and R2. Then its general solution is like this. C1 e to the R1t plus C2 e to the R2t. Okay. Second case, you got 2 complex zeros, roots, what you say. So their normal is like this. R1 equal to lambda plus mu I. The second one is lambda minus mu I. Then your general solution will be like this. C1 e to the lambda t cosine mu t plus C2 e to the lambda t sine mu t. Okay. So that's the solution when you have 2 complex roots. The third one, you got repeated root, say R. Then your general solution will be C1 e to the RT plus C2 t e to the RT. So whenever you have been given a second order linear homogeneous equation with constant coefficient, what do you need to do? Write down its characteristic equation and find its zeros, find its roots, see which situation, then pick the right one. You solve it.